Welcome back to Joint, Conditional, and the Two Laws That Run Everything, Part 4 of 8. In Part 3, we defined independence and warned that uncorrelated is not the same as independent. Now we combine conditioning with averaging to build the single most useful object in the course, the conditional expectation. We compute Sam's expected return in each regime, then make the conceptual leap that everything later depends on. This object is itself a random variable, the very thing regression estimates. First, recall the expectation, or mean, of a discrete random variable. Its probability weighted average value, the sum of each value times its probability. For Sam's portfolio, using the marginal of x, the unconditional expected daily return is minus 2 times 0.20 plus 0 times 0.45 plus 2 times 0.35. That is minus 0.40 plus 0 plus 0.70, which equals 0.30%. So on an average day, Sam's strategy earns 0.30%. Fine, but Sam never trades on an average day. Sam wakes up and sees the regime. So the relevant object is not this bland, it is the expected return conditional on what Sam knows. The conditional expectation of x given y equals y is the mean of x inside the conditional distribution from Part 2, each value times its conditional probability. On calm days, with conditional probabilities about 0.071, 0.50, and 0.429, it is minus 2 times 0.071 plus 2 times 0.429, which works out to plus 0.714%. On stormy days, with conditional probabilities 0.50, 0.333, and 0.167, it is minus 2 times 0.50 plus 2 times 0.167, which is minus 0.667%. So Sam's strategy earns about plus 0.7% on a calm day and loses about 0.2% on a stormy day. The single unconditional number, 0.30%, was a blend that hid two opposite stories. Here's the conceptual jump everything later depends on, so slow down. We computed two numbers, one per regime, but the regime y is itself random. Before the day starts, Sam does not know which it will be. So the expected return for whatever regime today turns out to be is not a fixed number, it is a random variable. We write it as the expectation of x given capital Y, conditioning on the random variable, not a specific value. Concretely, it outputs 0.714% when y is 1 and minus 0.667% when y is 2. It is a function of y alone. Once you know the regime, you know its value. That is the precise sense in which it is the best forecast of x you can make using only y. This object, the conditional expectation function, is, quite literally, what regression estimates. Hold that thought all the way to week 2. To summarize Part 4, the unconditional mean of Sam's return is 0.30%, but that bland number hides a plus 0.7 on calm days and a minus 2/3 on stormy days. The key leap is that because the regime is random, the conditional expectation is itself a random variable, the best forecast of the return from the regime, and the very thing regression estimates. In Part 5, we prove the first great law connecting these conditional means back to the overall mean, the law of iterated expectations.